Well, thank you for having us. Jeff asked recently, and when Spees asks, try and say yes. But we're grateful for the opportunity to speak to the group today. My name is Khanti. I'm the Director of Product at ConnectDER. I know a handful of folks on the call, but I also figured it would be more fun and interesting to invite a few of my esteemed colleagues from ConnectDER. So we have Nora Lardner on the call as well. She's our Director of Field Ops and Training. Also Doug Doherty, who joined us recently as a Field Apps Engineer and is based out in California. So they'll be helping me with some of this presentation as we go here. Let's see. All right, so some of the topics, I believe we have, is it 45 minutes? Is that all we have?
Sure.
Okay.
Yeah.
So I'll try and keep moving here because we could easily go long, and if we have extra time for Q&A or for any of our appendix slides, we'll be happy to jump in.
Yeah, we would like you to try to do 45 minutes with 15 minutes of questions and answers. If you run a little bit longer than that, I think that we could be okay with that. People could start putting questions in the chat as you go along. That might help.
Okay. Well, we will do our best. We'll go over kind of an introduction to meter socket adapters, what they are they new, specifically some more information about connectors, product lines in particular. We'll jump into codes and standards relative to MSAs, which Doug will cover, and we'll wrap up with some information from Nora on our market approval and implementation processes. How are MSAs generally approved with utilities, the adoption progress that we've been making, and some installation methods and how they differ. And then we'll wrap up with some Q&A. So start out with an overview of meter socket adapters. What are they? I assume a good chunk of this group has at least a preliminary understanding of what a meter socket adapter is. Also commonly referred to in the industry as a meter collar, but not so much in the standard space. So we try and stick with the MSA name and acronym. But basically, in a nutshell, an MSA is a very unique, fairly new device that essentially opens up the door to other locations for connecting DERs to the home. It's primarily a residential product. Historically, we've had to connect into the home, and we have code and standards that have limitations to how that's done. And the meter socket adapter gives us kind of a new pluggable interface on the outside of the home for connecting customer-owned devices on the load side of a utility meter. Almost all of them in the space are very similar in terms of form factor. Plastic housings, copper conductors, essentially a gateway that passes power bidirectionally through it from the grid to the home. So it can pass power from the grid to the home to power loads, during normal operation, as well as can feed power back to the grid for export applications. Most homes are compatible with MSAs, not all, just like any technology is not a one-shoe-fits-all, but many residential homes are compatible with MSAs. And really one of the primary reasons that we'll mention as to why meter socket adapters are valuable and sought after is because it really goes after one of the largest barriers to adoption of electrification solutions, and that is our electrical infrastructure in the home, in terms of undersized, inaccessible, difficult to access service panels that often need to be upgraded just to allow interconnection. So there's a number of manufacturers in the space. We are one of them. We've been doing it for quite some time, but they are not new. It might seem like they're new to some, as more kind of bigger names in the space, like Tesla, for example, have introduced, the backup switch. But the reality is that utility companies themselves have had meter socket adapters for quite some time. They've used them for a multitude of different purposes. For example, whole house surge protection, meter form conversion, and other applications for them. ConnectDER was one of the pioneers in the space for DER-based meter socket adapters, so solar PV applications, electric vehicles, energy storage, etc. Over a decade, the company was formed around 2011. We now have over 40,000 meter socket adapters deployed across the country. Roughly just over half the country, we have utility approval and growing every day. So a couple examples on this screen. You can see our latest product, the Islander, there in the upper left. Going across the right, you have Tesla and Enphase islanding meter socket adapters. Lower left, the good old standby GenerLink for portable generators. The middle there is an example of a surge suppression meter socket adapter. In the lower right, I think that's the renewable meter adapter, the RMA by San Diego Gas and Electric. So quite a few examples to point to in the space. So why use a meter socket adapter, right? We've been connecting solar and other DERs to homes for quite a while. What makes an MSA unique or special? And there's a number of them, but really, if you boil it down, an MSA essentially simplifies and standardizes how we connect DERs, how we connect current sensing CTs, how we can connect isolation devices, MIDs, microgrid interconnection devices, in a single place on a home across multiple different use cases and technologies. And really, as I mentioned earlier, we are trying to address the single largest obstacle, which is upgrading, replacing our service architecture inside the home. This is an expensive endeavor that gets passed to the homeowner to upgrade their panel, your MPU as it's known, or upgrade their whole service. And in parts of the country, such as where I think a lot of the audience for this call is in California, where your main service architecture is a meter main combination or an all-in-one socket and breaker box, it's especially challenging to kind of cut in your typical, CTs and isolation, transfer switches, and even just your typical supply side connections or your source connections to a service. So you end up having to shift or relocate a lot of circuits to a sub panel, which is a solid day's worth of work for a highly paid, highly qualified electrician. So a meter socket adapter essentially can bypass that challenge by creating that point of interconnection or that point of data collection directly behind the utility billing meter and avoid having to relocate all those circuits or wait for a utility, which in some cases I've heard can be upwards of 3 to 6 months to facilitate a service upgrade, a service replacement. Plus, if you're lucky, maybe $3,000 to $5,000 in labor and materials for that upgrade. If you're not lucky and you have an underground service, perhaps going underneath a sidewalk, maybe you're in the $15,000 to $25,000 range. So it's a significant barrier. So transitioning over to more about ConnectDER and the offerings that we have. We have 3 primary product lines: solar meter socket adapter, EV meter socket adapter, and our most recent is our islanding or our Islander meter socket adapter. If we have time at the end of the presentation, I do have a slide on each one to show a little more detail on each. So we'll start off with kind of a high level of each, and then we'll see if we have time for more. But essentially, the solar MSA has been our bread and butter for over a decade. I was actually installer back in the day, and roughly 10 years ago now, I stumbled across ConnectDER's first generation solar MSA here in Vermont, where I am based, and was blown away as to the value proposition of what it did simply by connecting a larger PV system to a home that was a lot more elegant, a lot more standardized than your quote supply side tap, as it called in the industry. But basically, it was launched in 2014. We've gone through 5 generations of the product, each generation improving the manufacturability, increasing the ratings, currently all the way up to a 200 amp pass-through rating, and an 80 amp DER circuit. So that's roughly a 15 kilowatt AC PV connection. We also just launched a variant of it that has exposed CT wiring out of it. So this has become more prevalent as TPO, third-party owned systems have grown and have required whole house consumption data at the point of interconnection. So we have a version of the MSA now where you have CT wiring out of the MSA itself. The next product that ConnectDER brought to market just over a year ago is the EV meter socket adapter. And this is the first solution that we brought that was not for a source. So as you can imagine, the architecture and the guts of this device are a little different because we're not connecting a source on the supply side of the service disconnecting means, which essentially net reduces the demand to the home. We are essentially feeding a load on the supply side of the service disconnecting means. So there are current sensors in there, CTs in there, and a load shedding relay that will monitor the whole house consumption of the house plus the branch circuit or the EV SE circuit, and shed that load should the combined consumption exceed either the continuous current rating or the instantaneous current rating of the home, so it can protect the service. It's really targeting 100 amp services, so smaller homes that have a harder time, thought they were signing up for a $500 EV charger or EVSE, but turns out they need a $5,000 service replacement. And then kind of the capstone product that we have brought to market is what we call Islander. This essentially is our version of what many know in the space as the Tesla's backup switch. It's our version of it. Essentially functions the same. We launched it earlier this year. It's same form factor as our other products, but it has a whole house grid isolation relay, also known as an MID or microgrid interconnect device within it. And it provides whole house isolation for energy storage systems behind the meter. And we have both analog and a digital version, which I can speak to more about or answer any questions on that if there's time. And we will be, from a roadmap perspective, we are actively working on the second version already of Islander. We expect it to launch in late 2027. One of the most significant features that it brings is it will standardize, and I think this will be of particular interest to the group, around a new digital communications protocol, tentatively dubbed the Universal MID or UMID standard, that's being worked on by a consortium of major industry stakeholders and is soon to become a new NEMA standard. So this will apply to MID, smart devices, smart breakers, smart panels, meter socket adapters, etc. I can't speak a whole lot more to it. I don't think we have time, but just thought the group would find that interesting. A lot going on this slide, but this is basically a very small peek into kind of the basic one-line flow of energy through each of the products. Again, if we have time at the end, We can blow these up one product at a time if there's interest. But essentially, it's very simple. A solar MSA, you've got a solar array, a solar inverter that feeds, back feeds power, except instead of going into a tap box or a backfed breaker, you're going directly into the meter socket adapter, has integrated overcurrent protection to meet code, and it's essentially a streamlined supply connection. The EV product, as I mentioned, it's feeding a load, so that has the potential to overload the service. And so you have, more advanced current sensing, as well as that load shedding relay, a redundant overcurrent protection device, should that relay fail, so that that load can be shed temporarily if the whole house consumption gets too high. It is worth noting, too, that the EV product is designed for EVSE, but it could be used with any controllable load. So anything that's okay to temporarily shut off, perhaps a hot water heater or a heat pump, something that doesn't mind turning off for 5, 10, 15 minutes. And then Islander, the current iteration of it is just a communications device, an isolation and communications device. So inside you have the MID, which is that relay that is just waiting for a command from our partner systems. These are, as Doug will mention, these are the 1741, UL 3141 PCS listed systems that are getting the telemetry, getting the data from Islander to essentially send an open command to that MID when the grid goes down and isolate the home for microgrid operation. All right. I think I'm about on time. I'm going to turn it over now to Doug to talk a little more about the standards and some of the codes that are related to and govern meter socket adapters.
Thank you, Khanti. I appreciate your time. Thank you all. Appreciate it. So going through some of our standards and oversights for MSAs, these are for all MSAs, but directly pointing out what we are compliant for. So ANSI NEMA C12.7 requirement for watt-hour meter sockets. A big one is UL 414, the standard for safety in meter sockets. So all MSAs are listed to the latest version of 414, including supplement A, B, and C. And here's the latest version of the NEC at that time of listing. Also includes heat rise testing and short circuit testing compliance. I'll just say this out loud. I did come on with the company this year, and they go above and beyond all of these oversights for sure. I've seen it in person. So C12.10, electromechanical watt-hour meters, and they're designed for ANSI form 2S, 12S, so 4-jaw and 5-jaw sockets up to 200 amps service. And the single SKU, the box that the installer receives, it does have the 5th jaw components inside of it, and it's installer friendly, has the torque values on it as well. So fully complete in that box if needed for the 5th socket. And then our Islander plus the partner BESS functionality safety validation via witness testing by California IOUs. So Khanti had mentioned that, the Islander plus the partner BESS gets us that UL 1741 and 3141. All right, next. So we are electrical equipment, so we do have to be applicable to NEC code and compliance. So involving all 3 of these components, I'm going to run through these. I won't go through each description of the codes. I'm just going to kind of jump and let you guys know what the codes that we are compliant with. And again, it resolves through all of our components. So service disconnecting means 230.70, 230.91, the integrated breakers. Service entrance conductors are Article 230.40. Grouping of disconnects Article 230.71. Next. And stop me if you all have a question. Spliced and tapped conductors, so 230.46. And we're going off of the 2020 and 2023 editions of the NFPA NEC code books. And then interconnected power production sources encompasses quite a bit of Article 705. So general sustainability, supply side source disconnect, so 705.11D. And then, of course, everybody loves grounding and bonding. So Article 250 and 705.11E compliant. Go ahead, Khanti. And finally, the microgrid systems and islanding. That's our Islander product. So Article 705.50, so interconnecting with a microgrid system. Article 705.65, reconnection to a primary source. And then Article 705.70, microgrid interconnection devices. And I'm going to speak on the UL listings. So the island, this is specifically for the Islander MSA, this slide. So UL 1741/3141 system compliance. So we see these two devices here. So on the left, we've got our meter can, our Islander product, and a data control cable going to another BES system. So the Islander, again, is NRTL listed, ETL as a standalone UL 414 device used with interactive equipment. Again, supplement A, B, and C. So ConnectDER is solely responsible for that 414 certification. So when connected to a UL 1741 system, or in this instance, a BESS system, the partner equipment is, again, NRTL relisted to UL 1741 and probably UL 3141, so for PCS, our power control systems, using the Islander as a critical component. And again, the MID and then that data cable sending that raw data to that device, which then controls that system.
Hey, Doug, I just want to add a nuance here in that this is the first time that ConnectDER has had a solution where we have this kind of codependence or relation with third-party equipment. And one of the things that's more unique about the product, the Islander product, compared with some of the others in the space. Some other companies have products, meter socket adapters that only communicate with their energy storage system. Tesla backup switch is a perfect example. What we're trying to do is create kind of a more of an open source solution that could work with a multitude of energy storage systems. So that's what we have now with Islander. It's a little more fun from a standards perspective. We essentially, as Doug mentioned, become a component, a critical component, and have some traceability to our partners' power control systems. Whereas our previous products, the solar and EV solutions, are essentially off-the-shelf, completely agnostic, non-communicative products that just work with a standard, 1741 inverter or, EVS level 2 EVSE. So just to make that clarification, but go ahead, Doug.
Thank you, Khanti. Thank you. And then lastly, our installer safety. We are incredibly safe. Everything is in our manuals, but just to mention, the ConnectDER products are, basically touch safe, quote unquote, to install. But it's always has to be installed by a licensed contractor, electrician, or qualified person. Follow the company's SOP, so their standard operating procedure for safety. Obviously related to OSHA and NFPA 70E. In the manual, it does say as a compliance, if the safety is unknown, stop work, do not proceed. PPE, you all know this, typically gloves, glasses, rubber gloves, leather, full arc fault, flash helmet, and the balaclava, Everybody hates that in California because it's always hot. Calorie rating clothing, and then the correct footwear. So the solar MSA and the EV MSA does require a neutral connection. Again, that's completed by a licensed installer, qualified personnel, or the local utility if that's required by their regulations. The Islander V1 does not require the neutral connection now. It's just a data only. But the solar and the EV meters do require that neutral for a multitude of flow. The data cable, again, designed and tested through NRTL. If the data cable is damaged, somebody cuts it, we lose connection to the DER in any way. The system will remain in its current state, but fail safe. It is a low voltage data cable supply. And then if communications are lost during utility outage, say big storm, and we've got power out for quite some time, the Islander actually has a tool on the bottom. You can see in the picture, it's kind of a sideways left-handed T, and it's just a screw that comes out. Obviously a human being has to come out, remove that screw. That's a captured screw. So by the way, if you're asking, it won't fall out. And that tool is just inserted into the bottom of the unit. It's kind of a push-pull system, lets you know it says if it's open or if it's closed. And so that mid override is available in the field if needed. And then finally, this cool diagram GIF, I guess it's called a GIF, kind of shows the entire system. So our utility meter, the connector Islander here, and how it kind of goes in. So we're going to have that meter lock ring. We're going to have two ceiling lock rings on the connection module that sits on top of our unit to keep that locked. And then the utility meter goes in front of that with the utility lock and seal. And, basically to kind of wrap up, all MSAs are basically the same. They install the same safety protocol. We have to adhere to NEC, NFPA, OSHA, and including, clearance and meter socket safety. So 110/26, got to be 3 feet with that voltage, no high voltage really there. So yeah, that's kind of the end of my slides. I will pass it forward to an absolute rock star, Nora Lardner. And thank you.
Thank you, Doug and Khanti. Tough acts to follow. And thank you to everyone who's been posting in the chat. I've been doing my best to keep up, but I'm going to ask Doug to take over from here to answer any chat questions. And if we don't get to anything, we can address them in a Q&A. But I really wanted to talk about how we get approved in markets. I go to a lot of events, talk to a lot of installers, AHJs. The number one question that we get is always, when can we do this, or when will we see this in our service territory? We would love to be approved by every utility in the country, but unfortunately that is not the case right now. There's really 3 paths to approval. There's the utility direct approval, which is when we go to a utility such as Green Mountain Power in Vermont, and we ask them if they would like to evaluate and approve our device. We've done really well with the friendlies, the utilities who are interested in making changes on their own. Now we're really using this utility direct approach with municipal utilities and co-ops who are more likely to make a change without a mandate. The other 2 are the most predictable, but longer approaches. So typically we either go through regulatory or a legislative approach. So we'll either work with a utility board, typically through an interconnection working group, and work on a standard where utilities have a set amount of time to update their standards and allow for MSAs. Legislative, very similar, where we would work with legislators. One of them will typically sponsor a bill that will pass, and we will then it will go into a regulatory approval timeline as well, which is why that's typically the longest. I will say that regulatory legislative, much more predictive. We're able to work throughout an entire state that way, since there's typically more than one IOU in each state. And then the hope is, and we work with the utilities on having unified standards so that it's as similar as possible from one utility to another. We can go to the next slide and talk about where we are already approved right now and where we have active work being done. When I look at this map, like Khanti, I've been here for, Khanti and I started right around the same time, and we only had, 4 or 5 states open. Open meaning allowed to be installed. Just a few weeks ago, we just hit having our 26th state approved, which is huge, since now meter socket adapters could be installed throughout half of the country in at least one utility. If we're looking at the orange states, these are our high, these are states where we've passed regulation or legislation where all of the investor-owned utilities have approved meter socket adapters, set a standard. The coolest thing about that is, we can't do that alone. So when we work on getting those approvals, we partner with other meter socket adapter manufacturers like Tesla, Enphase, Generac. So we really do work together to make sure that it's an acceptance, not just, us pushing our products. The blue states are where we have active legislation or regulation. Big ones are New York, Michigan, Maine. New York, we're working with the Public Utilities Commission. Actually, also in Texas, we're also working on a legislative campaign in Texas. So we do expect to add those 2 major markets within the next several months, which will be great. So that would be acceptance again of all MSAs, not just connectors. Also with the munis and the co-ops, we love working with them. We do have this keyed out so that you can see where at least one utility is approved. This is all also on our website. So there's a link to show where you could install today. Other manufacturers, again, their list will look pretty similar since we do work together on these approvals. Well, we can go to the next one. I just wanted to touch on the installation methods. This is a question that comes up a lot. Again, there's really 3 types. There's the utility installed, which is what's the most common in California. Perks here, Doug talked a lot about PPE and safety. This is going to be the safest way to install or least risk to the contractor. The utility will go to site, pull the meter, complete the installation, and then alert the installer when the installation is complete. Then they can go back, commission, finish out, and close out their project. Most predictable, don't have to worry about what's inside of that meter, having a licensed contractor on site since the hard part is done. The negative here is that you are beholden to utility timelines, which, I just saw in the chat earlier, could be up to 18 months. We're typically seeing about 6 weeks if a utility needs to go to site to install. Also, a lot of utilities, especially in California, will have a fee to go out and do the installation. Next, we have the joint meet, which is the most coordination. It's when an installer and a contractor and a utility will all need to be on site together. The utility will show up, pull the meter. Installer will install the MSA. Utility will reseal and then leave. Sometimes an inspector is also required to be on site. The one perk here is that it could potentially speed up the timeline for inspection, since if the work is done, installers could leave site same day with an inspection pass rather than having to call for a second inspection. It does require quite a bit of coordination for the joint meet territories. And then the last, which is my favorite, is the third-party install. It's where a qualified person or licensed electrician is able to go to site, pull their electric meter, install their meter socket adapter, let the utility know that it's complete, for the utility to go out and reseal it. The obvious perks here are just, being able to stay in control of your project as much as possible and complete your install same day without any additional truck rolls. I was in New Jersey yesterday, which is actually at a half-day AEI conference, presenting on meter socket adapters, and the inspectors brought up that New Jersey installers have actually done a pretty nice job doing this safely and in a compliant way. We've been approved in New Jersey for about 2 years now, and they haven't had an inspection fail in a year with an installer pulling their own meters. So that was a really fun fact for me to hear. So glad to share that here with this group. That was it. I was going to just do a quick at the end and let you guys know how it worked. We do have our contact information here as well. All of our direct emails, so that anyone here can get a hold of us if they have additional questions that we're not able to get through in the Q&A portion.